Hello everyone, today we're going to be talking about disks, partitioning, bootloaders and all the things that new users get stuck with when installing any operating system, whether that is Windows or Linux. Now most people get their PCs from a shop and it's already got Windows on it, so they don't have to worry about disks and partitioning and stuff because it's already pre-installed. But I assure you all the things I'm going to show you today, every single computer's got them in one form or another. On your machine you'll have a disk, and it will have a certain amount of space. When you start your computer, what it's looking for is a reason to boot, and so it will look on the disk and it's looking for a bootloader. In the past you will have had something called an MBR, and that's called a master boot record. So on computers that are really old, this would sit on your computer, and what your computer would do, it would boot up, it would look for the disk, and when it found the disk it would find the master boot record, and the master boot record would say you're booting from this machine, and then it hits something called a bootloader. So your bootloader is responsible for determining what it is that's going to boot from this machine. So it could be Windows, it could be Linux, it could be anything else. So you've got your master boot record. That tells the machine to boot up the computer, which then finds the bootloader. The bootloader then determines what's actually going to load. And then if you're running Windows, it would boot off Windows, and that's where the story ends. So that's what your computer would have looked like in the past. And so essentially, if you're going to imagine around the year 2000 all the way up to probably the mid 2010s perhaps, you'd have had machines in this format. So you'd have a continuous disk that boots off a master boot record, which calls a bootloader, which then calls Windows. If you want to look at it from Linux turn, it still worked the same way. The bootloader for Windows was called something like WYM, so it's like the Windows bootloader. For Linux you'd have something called grub, so grub grand unified bootloader or something along those lines. So again, the older computers, you'd have this master boot record, and if the computer found the master boot record, it would then look for the bootloader, which would be grub. Grub would produce a menu for things to boot into, and one of those things would be Linux, whether it's Ubuntu, Debian, Mint, whatever. So how has that changed in modern times? Well, now for Windows to boot, you need a various number of partitions, and one of those partitions is called the UEFI partition. So if we put a little marker there, everything to the left of that is your UEFI partition. So we can put a little circle in here, and what your computer does, it boots up, it looks for this UEFI partition, and this UEFI partition has details of all the things that it can boot on your machine. Okay, so then over here you would have your Windows. Likewise with Linux it's the same thing. You have the UEFI partition here and it boots into Linux, but it still needs grub. So it still uses, most Linux distributions still use grub, so you can imagine that therefore grub sits there. So quite often people want to install Linux, and it's important to determine whether you're A, using an old machine that uses a master boot record, or it's a UEFI machine, a more modern machine that's got an UEFI partition. And modern versions of operating systems like to have this UEFI partition to be able to work. So you can use your BIOS to determine this, and what you have to do is what I'm doing here. You reboot your computer and you press the relevant function key to enter the setup, and then you scroll along to the boot here, as you can see here, and you'll see that I've got an option for UEFI, or I've got legacy, and legacy means it's going to use the master boot record. And quite often the mistake people make is they'll install the master boot record version of the operating system, and then when they try and reboot their computer it doesn't show up because they've installed it to the master boot record and the computer's looking for the EFI partition. So I'm going to show you here what you need to do. So if you're in this boot menu and you see that it's EFI, then you need to make sure that when you create your Linux operating system on your machine, that you also have an EFI partition. And where you install the bootloader is also very important. So let me talk about bootloaders and partitioning. So imagine this is your only disk on your machine. Okay, this under Linux would be called something like dev SDA1, or you can just call it SDA1. Under Linux, the entire disk will be called SDA, and it lives under the device folder, so it's device SDA. But all you need to know is the entire disk is dev SDA. Okay, so if you're booting using a master boot record, i.e. legacy, then when you install the bootloader, you have to choose dev SDA to put the master boot record. However, if you are installing to a machine with an EFI partition, you have to choose dev SDA1. The reason for that is under legacy it's looking on the entire disk for master boot record, so dev SDA. Under EFI partitioning, it's looking for the EFI partition, so you have to put when you want to choose where to install the bootloader, it has to go into dev SDA1. Okay, so that's quite important. So I know what you're thinking. You're thinking, what if I have two disks? Well, the second disk will be called dev SDB. So the first disk is called dev SDA, and the second disk is called dev SDB. Now it is possible to put an EFI partition on each disk. So essentially you could have one operating system on this machine, one operating system on this machine, and the bootloader for each of them goes in their own EFI partition. Now what will happen when you boot your computer? Your computer is set up to look at one of the disks. One of the disks will be considered the primary disk. Okay, so by default this one would be a primary, and in the olden days it would have been called master and slave, but we don't use that terminology anymore because it can be considered quite offensive. So this is called primary and secondary. So your computer will be set up, and what it will do is it boot up and it will say, where's my primary drive? Primary drive's there. Has it got an EFI partition? Yes it has. Can I boot the operating system? Yes I can. Windows, Linux, whatever it is, it will boot. If it doesn't find an EFI partition there, what it should do, and you can look at the boot order of your computer, as I'm going to show you here in the BIOS settings, it should then fall down to the next disk along. So if it doesn't find an EFI partition there, it should fall down to this one. It will use this EFI partition, and it should boot from the secondary drive. And in essence, you're basically making that the primary drive and that just another drive. So if I take the EFI partition out of there, this actually becomes primary, and this becomes secondary. Now if you really want to dual boot and you want your grub menu to have all the operating systems, so let's do this over one drive first. Let's pretend we've only got one drive on our machine. Imagine this is your system, so you've got an EFI partition and you've got a Windows partition. On most machines, when you buy them from the shops, you'll actually have three partitions. The first partition will be EFI partition, and that contains all the information that the system needs to boot. And then you'll have the Windows partition, and that's where your Windows lives, and that's where you do all your work and put all your files, etc. And then quite often you'll have this recovery partition, and one of the things when you boot up is the option to recover your disk. And what all it will do is wipe that Windows disk and put that recovery image over the top. So that's how your recovery works when you're using something like Windows. So if you wanted to dual boot on a machine with one disk like this, what you need is another partition. So the way you do that, within Windows you've got something called the disk image tool, and what you're going to do is shrink the Windows partition down. And so say this disk is 1 terabyte in size. Let's do that. Let's put some text in. So your disk is 1 terabyte in size. Okay, that's the entire disk. So let's put a square around the whole thing like that. So that's your drive, 1 terabyte. This first EFI partition, the minimum it's going to be is 512 megabytes, but quite often it's 1 gigabyte. So, and your recovery partition might be, say, 20 gigabytes. So a terabyte, loosely speaking, is 1,000 gigabytes. So let's change that to be the same. Now realistically it's 1024 gigabytes, but you know, 1,000 gigabytes is a nice round number, so we'll do that. So 1,000 take 21 is 979 gigabytes left. So Windows, when it's installed, will always take up the maximum amount of free space it's got available. So if you've got a 1000 gigabyte drive or a terabyte, and you've got a gigabyte for the EFI, 20 gigabytes recovery, it will use the rest. Now in reality, your Windows probably only needs that amount of space. So let's be generous and say that that is about 200 gigabytes. So what you can do is you can shrink your Windows partition down to the amount of space that you think it'll actually need. Now what you want to do, it'll suggest the minimum size it can go down to, but you want to add a couple of more. You probably need to add a lot more in terms of space, in case one, Windows updates take up a lot more space, and two, if you decide you're going to install games, you're going to install any more software, etc., you need some space available. But let's just say it's 200 gigabytes, so that leaves 779 left. So you can shrink your Windows down using this tool down to 200 gigabytes, and that leaves this space here of 779 gigabytes, and you can install Linux into this space here. And as long as you install, when you install, you choose DevSDA1 as the place for your bootloader, it'll put the fact that Linux is on your machine into that bootloader, and when you boot up your machine, it will boot up and it will say, do you want to boot into Windows or do you want to boot into Linux? And that's how you boot Windows and Linux. But you have to make sure you get DevSDA1 as the place where your bootloader is. What happens if you have two drives? Well, you can put Windows back as it was there. So leave Windows full size, EFI as it is, recovery drive as it is. And on this drive here, all you want to do is install Linux. And you can use one single partition. But the important bit is, at the point where you're choosing which drive the bootloader is on, you have to choose that one there. You have to choose that EFI partition, which is DevSDA1. So if you've got a two drive system and you install Linux on the second drive and Windows is on the first drive, when you're choosing where to put the bootloader, you put it in the same partition as the EFI partition, which is typically DevSDA1. There are other ways you can partition your drive when it comes to installing Linux. So typically, a lot of modern Linux distributions have one partition. So ignoring the fact that you have the EFI partition, actually, let's put the EFI partition in because I don't want you to think that you can get away without one of those. Somewhere or another, you need one of these EFI partitions, unless you're on an older machine, in which case you need the master boot record. So there we have our EFI partition, and then we have the other partition here, and that's where you'd put Linux. Now, you could have one partition, and what this partition would be called is simply that, and it's called the root partition, and that's it. Every single folder would then appear under that partition. Now, the benefit of doing that is the easiest way to install it. All your files, all your folders, everything goes under that one drive. Now, you still have all your directory structure in place, so you have all your home folders and documents and stuff like that, but they're all essentially sitting on that one partition. What some people do is they split the drive up into more partitions. So you might have a root partition, and that's got all your files and folders under it that are required to boot the operating system and run the operating system. But over here you would have home. Now your home partition, that's used for all your personal documents, your videos, your pictures, your music, your files, everything that related to you, or your settings and all that sort of stuff sits in that home partition. Now the benefits of doing this, so incidentally when it comes to booting, it still works the same way. It's going to boot from the bootloader in the EFI partition, it's going to use grub and it's going to say where's your operating system, it's in there in the root partition, and off you go. It's going to find all that out for you. The benefits of having your home folders in a home partition is that if you decide that you want to reinstall the operating system, all you have to do is reinstall over that root partition, and you don't have to touch this at all, and it will just install your operating system into this root partition, which means your home files and folders stays the same. Now it's worth mentioning that if you're thinking that, hey, maybe I'll do that, and then if I run Ubuntu, say, and now I want to run Linux Mint, I'll just install Linux Mint over the top of this and it'll work fine. Now the problem with that is if you start using different desktop environments, different file systems, etc., then the settings in your home folder aren't going to match up with the operating system you've got. So I'd be very wary about doing that, but you should be able to restore the same version of the same operating system and it should work fine and leave all your files and folders perfectly fine in the home partition. Now, what some people do as well, imagine your machine doesn't have much memory. So let's say your drive is 500 gigabytes and your memory, let's draw a little box for memory, is 4 gigabytes. So you've got 4 gigabyte memory and you've got this 500 gig hard drive. Now if you start running lots of programs in this 4 gigabytes of memory, say you're editing videos, because that's quite hefty, it may well fill up to the point where you've got no memory left, your machine's chugging along, it's ground to a halt, and there's not much else can happen. So either, depending on the application, either the application will crash or your system will just completely grind to a halt. And that's not what you want to happen. Now if this is happening on a regular basis, then there's something you can do which is called create a swap partition. So if we take our home folder here, we can shrink this down. So say it was 500 gigabytes, we know that's going to be 1 gigabyte. Let's be ultra generous and give this 50, which leaves 449 gigabytes of space for the home partition. Right, so for all your files you've got 449 gigabytes left. So what you could do is you could say take 8 gigabytes of that and create a new partition called swap. Now what happens here, right? So you got your 4 gigabytes of memory, okay, and every time you put an application on there and it's running, it's going to take a little bit more memory. So let's break this down into small chunks. Okay, so every time you add a new running program, it's going to use a bit of the memory up. So 1 browser tab, 2 browser tabs, 3 browser tabs, 4 browser tabs, 5 browser tabs, bang. Okay, so by the time you get to the 6th one, what actually happens in a browser is it just kills one of the tabs off. Memory management in things like Chrome and Chromium and Firefox is actually really, really good. What you could do is, if you've got this swap space over here, what will happen is it will look for any one of these applications, and if it's idle and not doing anything, it will copy that into your drive. So essentially that's freed up some memory because that application there has gone into your swap. As that fills up again, if you add another one, you'll take another one of the things and drop it into there. So as long as you've got enough swap space, it will continue to do that. Now, on a mechanical hard drive that you used to have in the past, this used to be really, really bad, and it usually meant you probably needed more memory in your machine, but it would stop your machine crashing, and it's essentially what's in your memory would end up as a file in the swap partition. And if you started using that application again, what would happen is it'd copy it from that swap partition back into memory, and you could continue using it again. But this journey from here to here is quite slow, and the fact that it's a mechanical drive would be quite slow because it has to read and write from a mechanical drive. Now you've got things like SSDs and NVMe drives. This isn't quite so bad, but you've still got the process of getting from A to B, which is limited to the pipe that it's got to go down. So, but it's faster than it was. So if you've run out of space, having a swap partition is sometimes a good thing. Now you can judge whether your machine continually needs swap or not and how much swap space to use, and often swap space is used for things like hibernation. So if you imagine you hit the button to put your machine into hibernation, what it does is it copies all these processes into here, because if you left it in memory, when you went to restart your machine, it wouldn't be anywhere. So when you hibernate, all your files basically go onto this swap partition here or onto a swap file, because you can just have a swap file on your home folder, but that's something different entirely. But you put your machine into hibernation, all your things that are in memory go into the swap partition, and as soon as you come out of hibernation, and say you're on a laptop, you lift your lid, you log in, what it does, it goes bang, 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 and obviously you still got the same limitation, so I guess what was idle before might stay in there, but essentially that's what's going to happen. So you've got an EFI partition, a root partition, a home partition, swap partition. There are other types of partition you can have. You could have a log partition. That's for servers really, all your error logs go into there. You could have a boot partition, and that's used for boot management. Less important nowadays, I guess, because you've got the UEFI that does most of your boot management for you. But that's essentially how your drive works. Now I want to go back to this thing here about the two drive situation and it knowing which drive to boot from. Now in this case you can see I've got two EFI partitions, and I said that if your computer can't find an EFI partition there, it will go and find that one instead and it will boot from there. But you can also force it to choose which is the primary drive. So when you go into your boot options within your BIOS, you can see you've got a list of drives here, and you can change the order that things boot from, and you can also change whether it's legacy or UEFI boot on some systems, not all systems, and sometimes you can have it dual, so you could have some with the bootloader and some with the master boot record, so you've got the EFI on one and then master boot on another, and it will pick the in order of the things that you've made it boot from. So essentially that's what I wanted to cover today. This is basically telling you how you organize your drives to make it work with Linux. So the next time you're trying to install Linux on a single drive, you need to shrink down the Windows partition, add a new Linux partition. You need to point that bootloader to the EFI partition. On a 2-disk machine, what you want to do is put the Linux on a partition on one drive, you leave your Windows where it is, but when you install your Linux and it asks you where do I put my bootloader, you put it in that EFI partition there, which is typically dev SDA1, and it's the one that's key when you're installing the bootloader. Sometimes it will default to dev SDA, you don't want that, you want it dev SDA1, and you need that EFI partition on one of your drives somewhere, because without an EFI partition it cannot boot from a drive. So let's prove the point. This is the GNOME disk utility, and you see I've got two drives on this machine I'm using here. I've got one 480GB SSD and I've got 128GB SSD. My machine is actually booting off the second drive, and this disk here, you can see the partition type is EFI, so it's got the EFI partition, and that's how the computer knows to boot from. That's how the computer knows it can boot from this drive. I've also got this partition here, which is an ext4 partition, and that's called an extended boot partition, and it's mounted at boot. So we've got essentially a boot partition, and then here this BTRFRS is where my actual file system and everything else is. So I've actually got a 3-partition system here of EFI, a boot partition, and then the main operating system. I haven't separated out my home folders in any way. Now on my other drive you'll see it's just a single file partition and it's ext4, and you'll see it's called dev SDA1. So what I was telling you earlier about when you're installing your bootloader, make sure it's dev SDA1, that's true unless you're using the second drive, because my second drive is actually called dev SDB. So if I was installing another operating system, I'd need to make sure that my boot is pointed to dev SDB1. So that's the key. Whichever drive you're using, you need to work out where's the EFI partition, and that's where I need to point my operating system to when installing. So here's another worked example. So I'm in GNOME boxes. This is virtualization software. So what I'm going to do is I'm going to create a new operating system, and I'm choosing Linux Mint. We'll give it 8 GB of memory, and we'll give it 50 GB of hard drive space. And you can see I've got BIOS here, so let's do the BIOS one first, and then we'll do a UEFI one second. So BIOS is the old way of doing it, like master boot record. Okay, so this is what I'm going to do. I'm going to create this drive here. I'm going to start Linux Mint. So I've started the installer. Let's quickly go through this. This got nothing to do with the tutorial, so we're going to choose a language, keyboard layout. We're going to get through to the partitioning as quickly as possible. So typically when you get to the installation type, it will come here and it will say, if you've got Windows on your machine, it will say install alongside Windows, or in this case it's just saying erase disk and install Linux Mint, and it's not going to give you any other options, it's just going to do it. But if we go into something else, you can see some of the things that you've got. So typically it's going to use the entire device. Now look where it's going to put the bootloader. It's already worked out where to put the bootloader, and it's going to put the bootloader into dev VDA. Now VDA, because it's a virtual disk, is called VDA, but on a normal hard drive it would be SDA. It's worth noting that some manufacturers used to use HDA and things like that as well, but it's essentially going to be SDA unless you're in a virtual machine, in which case it is VDA. And you can see it's 53 GB in size. That's where it's going to put the bootloader onto that disk there. And so it's already worked out where it needs to put the bootloader. And you can see here you've got dev SDA. Now, if I wanted to, I can create a new partition table, which is what you'll need to do, because this is where you're going to work out how to do it. So in this free space here, you're going to create your root partition. Now, if you wanted it to use the entire drive, you just set the mount point as / and click OK. So ignoring the little 1 MB either side, you're going to have your root partition all across the drive, and that's it. Everything's all on the drive in one partition. Now if we're talking about what I was talking about earlier, what you could do is still have your root partition. You could have that as 25 GB. It says megabytes, but 25,000 is 25 GB, like that. And then in the free space here, you could choose home. And likewise, if you wanted to have a swap partition of 8 GB, you make that 20,000. And then in the last bit, you could change that. You change the use as, and then you can make it swap. So in this sort of setup, your Mint would install all the system files and any applications into this root folder. All your documents and videos and music, etc. would go into this partition, into the home partition, and then this swap area would be used for when you're running low on memory. It would move idle applications into that swap partition. So that's how that works. And the important thing here, because it's master boot record, is dev VDA. You don't want to choose dev VDA 1 because that will break your system. You don't want to choose dev VDA 2 because that will break your system. It will not boot. You need to boot from dev VDA. Now the Windows setup has said there's no EFI system partition found. This system will likely not boot. It will, because we've chosen to boot as master boot record legacy when we first created the machine. So we're going to click continue, and I'm going to let it install. And we're just going to do that, and it will work. And we'll finish up the installer. And we'll call this Gary, and then we'll call this legacy. Single password. There you go. And away you go. That's going to create a version of Linux Mint. So we are. You can see it's still a virtual machine. So if I press enter here and boot back into it, you can see it's picked up Linux Mint and it's going to boot in to Linux Mint. And you can see it says legacy up there, and there's my user, single letter password, so you know that's the machine I've just created, and that's legacy boot. You see I've got the partitioning right, and I put the bootloader to boot from dev VDA. Right, so here we are in the legacy version. So what we're going to do is go into disks, and we've got my 54GB hard drive. You can see I've got one ext4 partition, which is 25GB. I've got one 20GB partition, which is for my home folder. You can see mounted at home, and then you've got the swap partition, and that's how I installed the system. Now if I press escape at the point of booting, you can see it brings up this boot menu, and you can see it's going to boot from the virtual disk first, and then a legacy option ROM, then DVD, and the IPXE. So that's how it's choosing its boot devices. So if I had 2 drives in here, you could see the order that it's going to boot in, and you could actually just choose which one to boot from. So I've deleted that disk off there now. I'm going to create a new one, and this time we're going to choose UEFI, like that. So we're going to UEFI bootloader, and we're going to change this to 8GB, and we're going to make this 50 again. Okay, so here we are back in Linux Mint again. We're going to run the installer, go through the usual setup routine, and again we're going to choose something else, and you can see we've got the same dev VDA here. Okay, right, so this is key this time. Okay, so we're going to create a new partition table. We're going to create an EFI partition. We're going to create that as 1000 megabytes, which is a gigabyte. Then we're going to create the rest as a root partition, but we're going to take 8 off there, so we're going to make that 44GB. And then under here what I'm going to do is create a swap area. But the key point here is you can't leave that as dev VDA. That's not where the bootloader goes. The bootloader goes into dev VDA1, and that is key. If you put it into dev VDA, it will not boot. It has to go into dev VDA1 or SDA1, or whichever drive you've got, has to go into that same one as the EFI partition. Now I'm going to click install now, and we finish off the rest of the install. I'm going to call this like that, and away it goes. It's going to copy and install. Okay, so that's finished installing, so we'll restart. Now we just remove the medium, and it'll start up again. If we go into our Linux Mint now, it's going to boot up. As you can see, it's booting up okay. It's going straight into Linux Mint, and that's because I put the bootloader to boot from the dev SDA1 partition, or VDA1 partition in this case, because that's where the EFI partition is, and that's the key distinction between legacy and EFI. If you've got it wrong in any case, then it won't boot up, and that's your reason. So if I go into the disk tool again, you see I've got my 50GB hard drive, and the first dev VDA is EFI, then I've got my root partition, and then I've got my swap partition as created before, and that's it. And if you go into the BIOS here, you can see I can go into the boot manager, and you can see these are the things you can boot from within the EFI boot manager within the virtual machine. So if I installed Debian on this machine on that same drive, when I boot up, it will give me the choice to boot into Ubuntu or Debian, and if I have more disks, it would give me that choice. But that's essentially it. And that is the end of the video. If you like it, give it a thumbs up. Any comments to make, or I've made mistakes anywhere, please let me know. And see you next time on Everyday Linux User.